Hi, and welcome to Undergrad Academy. Today, we are starting a new series on computer organization and architecture. It is a very important topic for GATE, UGC NET, or any other competitive exam. And today, we will discuss a small introduction of computer organization and architecture. Before we start, I request you all to please subscribe to Undergrad Academy and press the bell button to never miss an update from us. So what is computer organization and architecture? It refers to the internal arrangements and operations inside a computer system and how this computer system performs the operations and why. And one most important concept is that on the execution of every instruction we give to the processor, there are a number of machine learning concepts and machine learning commands at the back end. So, what is an instruction? Well, we will discuss this later in our later lectures. But for now, remember that an instruction is any command like addition, like we are adding 2 plus 3. So this is an instruction. We are giving an addition instruction. So what we will learn and cover in this course, we will first discuss the introduction of computer architecture and organization. Then we will discuss the von Neumann's architecture. It is the most basic concept and most basic architecture in computer systems. Then we will discuss the top level view of a computer evolution and performance, like when it was developed and when it was invented and how it evolved in terms of performance and some other concepts. Then we'll discuss the instruction set of a processor and encoding techniques. Both of these, the instruction set and the encoding techniques, are based on programming concepts of assembly language, like what kind of machine learning instructions are involved. Then we'll discuss the internal and external memory, like RAM and ROM, secondary storage, how these memories will affect the system performance. Cache memory design, input-output module. This input-output module is an important component inside the computer system through which we can communicate to the processor. And if it is not present in the computer, then we cannot give commands to the processor and the processor can't process and provide us the result. That is, input-output is a medium between us and the processor. Then I will discuss the direct memory access, that is DMA. Direct memory access transfers the data directly from memory to the input-output devices without involving the processor. These input-output devices like keyboard, mouse, etc. and memory is what? RAM. So this direct memory access will transfer the data directly from memory to the input-output devices. Then we'll discuss the computer arithmetics, like all the shift operations, loops, jumps, etc. And in the end, we'll discuss the control unit multiprocessor. It is a core architecture. Why study this subject? Because you want to build a software that people use, and obviously it needs performance. It needs good performance. You need to make a purchasing decision or offer expert advice, like what kind of computer should I buy. So both hardware and software affect performance. Like algorithm. If the algorithm is too complex or large, then the system performance will be lessened, will be reduced. Language compiler architecture determine machine instructions, like how many instructions are there in our computer system. The more instructions, the more time it will take to execute those instructions. The more time it will take to execute those instructions, and the performance will be reduced. Processor memory, it determines how fast instructions are being executed, and number of cores determine the overall performance. Like if number of cores are more, the performance will be more, because all the cores run in parallel, execute instructions in parallel. This is a very important point, that all the cores run in parallel. Now finally, let's discuss the introduction to computer architecture and organization. Computer organization refers to the internal arrangement of computer. It refers to the operational units and the interconnections that realize the architectural specifications. Examples are the things that are transparent to the programmer. Like it includes design of a processor, memory, and input-output circuits, which are not visible to the programmer. whereas computer architecture refers to those attributes of a system that have a direct impact on the logical execution of a program. And it refers to those attributes that are visible to the programmer, describes the features of computer family. Examples are the instruction set, number of bits used to represent various data types, input-output mechanisms, memory addressing techniques. For example, the fact that the multiply instruction is available is a computer architecture. Like if this multiply instruction is available in the computer or not, then it comes to what? It refers to what? Computer architecture. And how it is implemented, what kind of interconnections we have made to implement this multiply instruction, it refers to the computer organization. Here I have a very basic example to define the computer architecture and organization. Here IBM 360 and 370. If the series like this 360 and 370 is changed, then we can say that both the processors have different architecture. But in the next example, there is IBM 370.xxx, that is 370.1, 370.2. If the versions is changed, then we can say that they have different organization. So now let's discuss the conclusion. We have discussed that on the execution of every instruction, there are a number of machine learning instructions being executed at the back end. So what is an instruction set? It is a collection of machine instructions, okay, and those are written by the programmer. And we need to learn assembly programming, that is low-level programming language concept, in order to learn instruction set of a processor. And one more concept, we have studied the introduction of computer organization and architecture, and we studied that different computer models may have same architecture but with differences in organization. Therefore, different models have different performance. So in the next video, we will discuss the different computer types and how the computer evolved in terms of performance. Okay, so that brings us to the end of this lecture. I hope you enjoyed it. Please like the video, share it with your friends, and comment your queries in the comment section below. Also, please subscribe to Undergrad Academy and press the bell icon. Until the next episode, goodbye and see you soon.